So this is the second tutorial for the open channel. As I mentioned before, we working with the Civil 3D to calculate the maximum flow in this trapezoidal channel by this information which is showing here: the discharge, the slope, and also the types of channel is concrete here. That's mean the Manning coefficient is 0.017, and the depth and width showing like this is the top width here is 8, and this is the bottom width is 4 feet, and the height is 2 feet, the height of the water. Here is showing the AutoCAD Civil 3D 2013. We have to go to analyze and then go to the design. There is a thing is called launch expresses. Go there. They will be open the new uh, screen or new layout as showing here. Uh, there is a culvert here, and there is a channel, inlet, hydrology staff. You can design the hydrology staff from here. There is the weirs for the hydraulic jump if you need to calculate the weirs from the dam. I'm interested today with the channel, so go to the channel. There is different shapes you have here. So you have a circle, on triangular, rectangular, and we have a trapezoidal. According to our exam here, or our example, we have a trapezoidal channel. So this is the trapezoidal channel, and this is the figure showing here. First we have to set the unit. We have here feet, and here we have in meter, so there is a unit here. You can change it to the or convert it. So here is the feet now. The section type here, we have to put the trapezoidal channel, and the bottom width is here, this one. We have here is 4 feet, so alright, 4 feet. And the side slope z, which is this one, is given to us like 2, and another side is 2 also, so 2 by 2. And the top depth, this is the top depth from here to the top, is 2.5. And the initial elevation here, this is the first reading by, if you go on site, and we have to just like specify the first reading in the level, which is the first slope or first elevation. You have to assume it here because this is showing in the field. We have to calculate that in the field, or you can calculate it by use GIS to get the contour line, and by find the contour line we can estimate which elevation you have. And if you get the difference between the first elevation and the second elevation over distance, that's mean the slope. So the first elevation, I would say 1 meter or 1 feet as example, and the slope as I given to us here is 0.012. so here 0.012. The coefficient for the concrete channel is 0.017. So here 0.017, and compute by Q, find depth. If you see here, there is a if we know the Q, you can find the depth. And if you know the depth and the flow is unknown, you can switch it off and you can find the depth by now the flow. So in this case, I have to use this one. And in increments here is showing how many steps you have in this channel from the first point to the end point, or they like the distance of the flow. So I will leave it as a 10, then I use run. We get like this. Here is showing the elevation, and here is showing the reach, and here the another column, or the y direction here is showing the depth. So there is another table, and the bottom here is showing the depth on the discharge in each depth, the area of section, the velocity, the weighted of parameter, the YC, which is the critical flow, the top width, this is the top width, and finally the energy. The energy is equal Y plus V square over 2G. So if you see, the energy will be increasing when the depth is go up. And here, if you see, the Y critical is increasing also. So in point 0.25 we have a discharge 0.358. So if you go to the depth 0.5, you see is go up. That means the Q is 1.88. If you choose 0.75, the flow is 2.452. Even we have the area will be increasing, the velocity, the the weight of parameter also, y critical, all of them will be increasing according to the Manning equation. So here we have a 1 feet, we get like 4.167. We have 1.2, we get a flow 6.3. The flow be increasing because the depth be increasing also. So here 1.5, 1.7, 2.0, and 2.5, and 2.25 and 2.5. We get the flow at 25.57. This is the peak discharge. After that, this channel will be flooded if you increasing the depth more than 2.5. And the final flow, the peak discharge for this channel is 25.57. If we try to use the pipe or sewer network, we can use this one also. Next tutorial we try to model or to make analysis for the another shape, like a circle or rectangular, and see the difference between the circle and the trapezoidal, and we will see.